Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 14 from the specimen paper B of the Cambridge 0580 new syllabus from 2025. This is a paper 2, the non-calculator paper, and here we have a question which is quite familiar from the previous syllabus of rewriting a recurring decimal as a fraction. So we have 0.38 recurring, and we have to write that as a fraction. And the standard procedure is as follows. First of all, we say, I'll put this up here in fact, let x be equal to 0.38 recurring. So which means x will be equal to 0.3. Now I'm going to write it out for a few terms along the 0.3888, continue on. Now, what I want to do, okay, there's different ways of doing this. This is the way I like to do it to make life, I think, a bit easier, is I need to have two expressions, two equations, you could say, in x, which has the decimal in such a way that after the decimal point, you have the pattern. The pattern here is the 8 is repeating. 0.38 recurring means it's 0.3 and it's just the 8 that recurs. Okay, if it was a dot on both of them, it would be 38, 38, 38. It's a dot on just the 8, so you have 0.3 and then you have 8 after that. That's how we should understand. Now, so I need to have two different equations in different numbers of x, which would start with basically 0.8888, like that. Right? So the first thing I can do is I can say, okay, if I multiply this equation by 10, if I take this equation and I multiply it by 10, I'm going to get 10x is equal to, and I'll have 3.88888, and that will give me something which will help me to have just the decimal, after the decimal point, the pattern. Now I need another expression also, or another equation you could say, which has the same kind of pattern, but with a different number of x's. So what I can do here is I can take the first equation again and I can multiply it by 100. If I multiply it by 100, I'll have 100x on this side, and I'll have 38.8888, continuing. So you can see here, my objective is to have two lines where after the decimal point I have the pattern. And the reason why, I'm going to call this equation 2 and equation 3, the reason why this is important is that if I take these two equations, if I take equation 3 and subtract from it equation 2, then what happens is I have 100x minus 10x, which is 90x, equals, I have 38 minus 3, which is 35. And what happens to all these is like 0.88, they cancel out. When I subtract these two lines, all of the decimal part will cancel out. They'll be gone because you subtracted them, they're gone. Okay, they're the same thing, exactly the same thing subtracted. And you're left with just these two parts here. So now we can say that means x is equal to 35 divided by 90. So we want to write it in the simplest form. So we have to see that the common factor in both of these is 5. So if we can think of this as 35 is 5 is, let's do it in there more. 35 is like 7 times 5, and 90, 5 goes into 90, of course it does because it ends with 0. So 5 goes into 9 one time, remainder 4, 5 goes into 48 times, 18 times 5. Then we'll cancel out, you're left with x equals 7 over 18. So 7 over 18 is what 0.38 recurring is equal to as a fraction. Okay, now in the past, in the old paper, the old syllabus where you're allowed to use calculators, then after you've shown these steps, you could check your answer in the calculator to make sure that you got the right answer. Okay, in this case, you can't do that with a calculator. You could try to just do 18 into 7 and see, you could try to do your long division and see, does it actually give you what you started with? If you wanted to check, so 18 doesn't go into 7, and then you're going to have remainder 0, so remainder 7 in front of the next 0. So 18 goes into 70. You got 18. You got 36, and then you got 36 plus 18 is 54. Okay, 54, and then plus another 18. That's going to give you 72. So it's going to be 3. Okay, because the 4 times will be that 3 18s are 54, and then you're going to have 54 to 70 is going to be how much is that going to be? That's 64. It's going to be 64. Okay, it's 16. So you put 16 in here, and so on. It's going to be a bit of hassle. Okay, but you know, you could try to work that out if you have time. Okay, but in the old days, you could just use your calculator and check, but it's a bit more hassle now to check. That's what I'm trying to say. Basically, here you have your answer. This is the procedure. You can't check your answer with the calculator anymore, as you could do. You could by long division if you wanted to go through the hassle of doing that. You might not have time to do that, but hopefully you don't make any silly mistakes on the way. So there we have the answer to question number 14. Other questions from this particular paper can be found in the playlist on the top right of the screen at the end of the video. Other questions from the topic of, and I'll put this as a separate topic, a separate category, recurring decimals to fractions, you'll find in the playlist over here. Other questions dealing with arithmetic from my new syllabus, or the new syllabus, my new questions from the new syllabus in this playlist over here. And the arithmetic questions from the old syllabus you'll find in the playlist on the top right. Thank you for watching, and see you soon.